Hi guys, I'm Soumya and I'll be solving the question assigned to me. So let's get started. Okay, so first let's read the question. The question says evaluate the double integration and the equation is this. So what the equation is actually root x cube plus 1. For dx, the limit is root y to 1 and for dy it's 0 to 1. So what will actually happen? First we'll integrate this part with respect to x keeping y as constant and the answer we'll get will be integrated with respect to y keeping x as constant. By iteration integral, we know it can be done inside out also. Okay, so let's write this. What will it turn to? So for 0 to 1 it was y, so we'll write dy first, and for root y to 1 it was x, so we'll write dx first. Then so basically the whole integration will be really easy, but what we'll be stuck at would be while putting the root y1, we'll get up to a very complex solution and this will not what we'll expect. I have solved this before and I'll show you what will turn out. This was the same thing we did it before. For integrating dy wala cheese, this will be the constant one, it will be out, and this is what we'll get after the first integration. And after integrating with respect to x, this is what we'll get. After putting up the limits, this is the final solution, the confused and the complex solution we'll get. Now this is not what we want. We'll want a simpler one, an easy one, and with a better lookout, of course. So what to do? I have got a really simple solution for this. Okay, so let's get started. I'll be using graphs. An easy graph, very easy graph. So what basically I'll be doing, I'll be substituting the values here in some other way, an easier way which will be easier for us to solve the question. So first let us look at this line. It's x equals to 1 and x equals to root y. Okay, and this is the line y equals to 0, by the way, and for this it's y equals to x square and y equals to 0. Okay, so what it will turn out from this step, what we'll get, just pay attention and you will understand it. 0 to 1, 0 to x square, root x cube plus 1 dy dx. So for root y, we wrote 0. For root y, we wrote 0. For 1, it was 1 only. For 0, it will be 0. And for 1, we'll write x square. So that's what we did. Now, magically, the answer would come up as very, very easy. It will be very smooth. Not something like this, but in a very simple and a beautiful solution. Okay, so first we'll be integrating this. We know we'll need to keep x as constant, so this whole term will be constant. Let's first do it this way. X cube plus 1, 0 to x square dy. Okay, now what it will turn at? Yeah, then this will be same, minus 0, x cube plus 1. This would be the solution after the first integration. That means we have reached here. Now what? Now even in easier part, it's just substitution. we'll be doing this. Okay. When we are gonna differentiate it, we'll get 3x square equals to 2t dt by dx. Okay. For your reference, I'll be putting what we got before. It was 0 to 1, x square x cube plus 1 dx. Okay. So dx can be written as from this 2t dt upon 3x square. Yeah. In easier part, x square dx can be written as 2t dd upon 3. We'll put this here and also this part. One thing to keep in mind, x varied from 0 to 1. So from where t will be varying? It'll be varying from yeah 1 to root 2. Okay. Okay, so let's get started. The limits would be 1 to root 2. Yeah. And we'll put it t to t by 3 dt. Yeah. For t, why t? Because x cube plus 1 was t square, so root x cube plus 1 would be t. And why 2t by 3 dt? Because x squared dx is 2t dt by 3. So that's what we wrote. 2 by 3 is constant. We put it out. Yeah. Why this? Because while integrating, we get tn plus 1 upon n plus 1 plus c. It's indefinite integral, so we'll not be using a constant here. So that's what we'll get. So that will be my bad. Yeah. This is the final answer. Yeah, it's way more better than this. Actually, this would also have helped, but this is an easier one, I guess. So that's what we'll do. I'll give you a review of what it was. See, that's the first page and that's the second page. The first page shows the graph and the first integration, and the second page shows the second integration. So that's all. Thank you so much. I hope you understood this question, and thanks. Bye.